So let's look at the Advanced Networks Forensics Lab. So what we've done is we've recorded a real crime or a suspicious crime activity, and the task is really to very quickly find out what really happened. So this is the typical route that an intruder might take to be able to get to a profit stage. They'll do some outside reconnaissance, which is very difficult to stop, looking at who is, looking at job advertisements and so on. The first sign that we normally see is some inside reconnaissance. So at this stage we see something like Nmap. So we might see a scan of all the hosts that are on a certain network using Nmap. And then we might see a port sweep on a certain machine to see if the machine is alive or not. And then from there, the intruder might then go and look at some exploit. So that might be some way of actually getting access to the system. So in this case, we're going to look at Hydra. Hydra will try and crack a username and password, a weak username and password on a system. And then they'll go and get a foothold onto the system. They might then escalate up through the levels and then on to profit. Okay, so the scenario that we've actually set up does go through these main stages as an intruder goes from this stage right to the very end. Okay, so the lab that we're focusing on is this one here. Okay, so the first thing to do is to open up the Wireshark trace. And it just takes a minute to download. So what I've done is recorded some sort of activity over a network. So there's a lot of background noise. An issue that we have is really to try and make sense of all the traffic on the network at a given time. So we're using the filters quite a lot. So just let me, rather than downloading the file, I'll just open it up from here. I have a copy. Okay, it's about 60 meg pcap file. Okay, so that's it. So just cancel that. And there we are. Okay, so we have lots of information in there. There's lots of background things. As you scroll through, you'll see there are sequences that look a bit strange. And a key thing is to be able to spot certain threats, certain malicious traffic from the trace. So what we're going to do is we're initially going to have a look to see all the network IP addresses that are on the network. So for that we would look at conversations, and this is going to tell us all the MAC addresses that were involved. So we can order that in terms of the number of packets that the MAC address has involved. Okay, so we can see most of the traffic is between these hosts here, and very little around the ones at the bottom there. For the IPv4 stuff, we can actually have a look to see what nodes cause the most traffic. Okay, so maybe between 12 and 13, there's a lot of traffic between them. And we can have a look at the TCP connections, looking at the port numbers and the destination ports. So this can be the server ports that we're looking at. Okay, and we can pick off a certain one from there, and then any UDP traffic. So typical with UDP, we see a lot of domain DNS resolution, a lot around Windows domain traffic, and not so much on other things. Okay, so that gives us a basic overview. If we're interested in any one of the streams, so we can actually take a stream that we're interested in, find it, and then we can follow the stream. Okay, we can also plot a basic graph of the connections if we need to. Okay, so the first thing that we're going to do is that we're going to find out what the basic ARP activity is. Okay, so the ARP filter should give us that. Okay, and there's a whole lot of activity that we can actually look at. So with ARP, host sends out an ARP request, and then we get an ARP reply. Okay, so 192.168.0.1 is asking for this network, the MAC address at this IP address, and then this is the reply telling the machine what its MAC address is. Okay, so that machine is online, that machine is online, so 11, 12, 13, 10, 11 there. So one little trick that we can do is that there's an opcode. So when we look at ARP, we actually find the ARP has what's called an opcode in there. So an ARP code 1 is a request. So if we wanted to look at that, that will give us all the requests. So that's an ARP. That's all our ARP requests in there. And an ARP code of 2 is a reply. So the replies will come back from all the hosts that are online. So this just gives us a quick 11, 12, 13, 100 are online. Then that's mainly the hosts, and there's an 8 goes online here, and then any other ones we can go down. So we can actually see which hosts are coming online and what's been discovered. The ARP cache is updated every few minutes. That's a bit strange. So you can see here there's a case of MAC spoofing there, or ARP poisoning. Okay, so the next thing that we'll do is that we'll actually look for all the sins. So we can do tcp.sin, tcp.flags.sin is equal to 1, and tcp.flags.ack is equal to 0. So this will show us all the sins that we've had. So the first sign of a web connection, the first sign of a client server is the sin, a sin and not an ACK. So let's open up this one here and let's have a look to see what was, oops, sorry, let's do that again. Okay, let's just open that up again and see if we can close that one. Okay, so tcp.flags.sin is equal to 1 and tcp.flags.ack is equal to a 0. Okay, so there's all the sins that have been generated. So let's try and open up one. Okay, so you can see here what's happened is that the user has accessed google.co.uk with a get slash, and then this is the result we get back. Maybe some images in there, and the keep alive is on. So rather than opening the connection and breaking it after each request and response, then we'll find that the conversation stays open. Okay, so that's now doing another get for some things, and then it just continues on and so on. There we go, we can actually see what the web browser agent at Mozilla in there from a Linux machine. Okay, there's a lot of information that we can find out from that. The cookie is stored there, and so on. So HTTP gives us a basic header each time that we get information, and then gives us the content. A 200 message means that everything's okay, and so we can follow each stream as we go along. So the next thing we're going to do is we're going to look at some basic information about the DNS, which is port 53 UDP. Okay, so what we get, these are all the DNS queries. So if we feed in google.co.uk, then the browser needs to do a lookup on that IP address to find out what it is. So we match here with this code, So the match up for google.co.uk, it looks for the A record, which is the IP address that's been registered for that domain. So, okay, so this is the query here. And we're asking for Google, and we're looking for the A record, which is the main IP address of the domain. And this is what we get back as an answer. And there's what the IP address is there. That's what's been registered by Google. Sometimes we might get a few addresses coming back. So for this one, for googleplus.google.com, we actually get a few IP addresses that we can choose from if we want from them. Okay, so you can have a quick look to see there's some camping holidays, splash.co.uk. So one person's obviously interested in woodland holidays, and I think another one is quite interested in ant farms and so on. So that gives you the basic details of the DNS queries from there. So the next thing we need to do is to look for the IP address and the MAC address of the gateway. So the standard way of doing this is to find a packet, find a packet that is destined for the internet, such as this one. Okay, that's a local address, that's the internet, it's a public address. Then we look at the MAC address, and in this case the destination will be the MAC address of the gateway. So in this case, just remember 1649 is the MAC address of the gateway. So when we communicate with the gateway, that's the address that we use. Okay, so let's go back to our ARP 1649, 1649, 1649, and let's actually have a look at ARP.opcode again, and we'll have a look at the two. And let's see if the gateway responds back, and where is it? Here it is here. Okay, 1649 at the end. So the gateway is at 192.168.0.1. Okay, that's the gateway. It just happens that this is a Sagicom network card and not a VMware card. So it looks like it's a real network adapter. Right, so the first piece of malicious activity is actually someone running Nmap across the network. Okay, so one way is to really search for the first signs of this type of activity. Okay, so this is all normal activity, and here we go here. So this is the sign of Nmap scan of ports. But earlier than that, we actually see a scan of the host. So with Nmap, if the host is local to the network and there's no router involved, then it will do an ARP scan, otherwise it will do a ping scan. So here we go. So this is a standard sign of Nmap doing a scan of all the hosts here. So the scanner is 0.12 and it's scanning the whole network. So we can actually find out, and this is the way the Nmap finds out which hosts are online. Whatever hosts respond back, it knows that they're online. So 13 is online, 100 is online, and that's 113, and that's us back out of the scan. Okay, so at this point in the trace, we actually have an Nmap scan with ARP. So now what happens is that we'll have a look to see if we can actually find the next problem or the next trace where the intruder, so if you remember 0.12 was the scanner there. So if we actually have a look, then here we go. A little bit later on we see all this SYN activity, and that definitely looks strange, trying lots of ports. So it's now found out the machines that are online, 1, 7, 8, 11, and what it's doing is a port scan across these 3 machines. So it's just a continual scanning of these machines for the ports, and there's pop and so on. So this is really where it starts, about here, packet 7385, and sorry, not quite, yep, that's it going through all the ports there, trying a SYN and then waiting to see if it gets a reply. So the host which has been scanned is 1, 7 and or 11, and it's been scanned by 12 again. So 12 was the one that did the ARP sweep. So that is now scanning the machines that are online. So what we can do next is actually have a look to see which machines have responded back with a SYNAC. Okay, the SYNAC means that the ports are actually alive. Okay, so we can see here's an example of a SYNAC for the server port. SYNAC there for HTTP. So what we'll do is we'll find our scan. Okay, so what we get is that if within Nmap, if the port is not open, then we get a reset ACK. If the port is open, then we get a SYNAC. Okay, so in this case, the SYNAC is coming back from here, which means that this port is actually open. Okay, so there was the SYN, there's a SYNAC, and then eventually what the scanner does is send a reset to reset the connection. Okay, so it doesn't leave the connection open, it does a reset straight away. The way the Nmap tells that a port is not open is that it gets a reset ACK. So we can see it's tried port. Let's have a look down here. It's tried port 1300 here with a SYN, and it gets back from that port a reset ACK, which means the port is not open. It tries the SYN as we've seen, and if it gets the SYNAC back, then it means that we have an open port. Okay, so in that way we can actually determine whether it's the type of scans, the ports. The Nmap can tell which ports are actually open. So what we get back, it depends on whether it's an open scan or not. Let's find our Nmap. Okay, so we just run Nmap. Okay, so the different types of scans that we can do with Nmap are these ones. Okay, so we can do a SYN, or we could do a connect. Okay, so the connect will go through and finish off the connection, where the SYN will actually leave it open. So that's the -S and -T are the options there. So we actually saw earlier that we get a reset. So this looks as if it's a connect scan that we've got. Okay. So the next thing we're going to do is we're going to have a look at, so now the intruder knows that the ports that are open. Now what they could try and do is to try and compromise, look for the vulnerability from it. So the next problem comes in when the intruder uses Hydra for FTP and tries to break in with a certain username and password. Okay, so what we'll do is we'll actually try and find that. And a response code of 220 gives us every single time we log in to port 21, this is what we get as a response. We get a 220. Okay, so the first signs of someone logging into FTP is with this. So what we'll do is that we'll have a look to see the packets around that first sign. So here we are here. Okay, so there's the connection. The connection being made to FTP. In fact, there's quite a few connections here. So what happens is that Hydra will make several connections at one time and then try a few passwords. So we see one connection here, another one here, and then another one here, all with different TCP source ports. Okay, so that's another one, and so on. So it's doing maybe about 5 or 6 different connections at the one time. And this is all the synapse that are coming back. So straight away there's quite a few connections being made. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's actually made about 10 different connections there to connect to the FTP server. So what we normally do is that we'll look for 220 and then we can follow the stream to see what Hydra actually entered. So we can see what's happened is that this Hydra is trying lots of different usernames and passwords. It's only trying 1, 2, 3 because it doesn't want to be locked out. So it just tries a few and then it will quit the connection. Okay, so some of the names that it's used, so we'll try another one. We can actually see it from the trace, actually, what it's given us. Now that we've found it, we can actually have a look to see what's going on. A lot of other background traffic there. Okay, so we'll go back to our filter. ftp.response.code is equal to 220. And then we'll just pick off this one here and see what it's tried. And so what we get is they've tried sys and anon and then test1 and password. Okay, so it goes into a username text file and it goes into a password text file and picks them off one by one. So now what we need to do is to find when the user actually got logged in. If we were to find this as a trace, how can we find what user account was the one that was compromised? And we look for 230 for a successful login and 530 for an unsuccessful login. Okay, so you can see here this is the first sign that the user has managed to log in. and we'll just have a look to see what happened. And there we go. There we go. There's the 230 message. 331 is password required. 530 user cannot log in. So this means now that this FTP server has been compromised. Okay, so now the user has broken in. So the malicious node in this case is 13. Okay, 13 is the one that's managed to log in. So how many times have they logged in? So let's look for our successful login. And there we go. So the first time was to do with the Hydra crack, and then all these other times are to do with the user logging in to the FTP site. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times they logged in. Okay, so let's have a look at what they've been doing. So we can then go and see what they've been doing on the machine. Okay, so they've logged in. They've then they do a present working directory, which is / top level. And then what they do is they do a listing. We don't see the listing here, but we could if we went to the associated stream, which is 256 times 5 plus 43. Hopefully we'll find that in a little minute. Okay, then they change to the directory folder, do another listing, change the top level, and so on. They then try to create a directory, then they create a order, and then change into the change the working directory into /order. Okay, let's see if we can find that out with the stream. Okay, so here, so look, 5 and 43. So the user does pwd passive and then does a list. Okay, so the list will give a listing. Here is the connection that's actually made, and that is made on port 16. Sorry, for the destination 1323. Okay, which is made up of this 5, the 5 times 256. 5 times 256. 5 times 256 plus 43 is 1323. Okay, so passive FTP sets up this port. The firewall will hear it and will open up the port to connect to the server, FTP server. So here is the connection that's actually made. So we should see a list when we look at that. There it is. Look, that's the listing, the FTP listing from the site. So we open up a new port and then we let it through, and that's our trace. Oops. So let's go back. Just quitted from the from there. Right, so we'll go back and so we'll have a look at our FTP. So it was ftp.response code response. Okay, so we can note down some of the things that the user's been doing. So let's have a look at this one. Okay, they've changed into directory, the upload file. Okay, upload a few files there. And then if we keep going through this, we should find there's a file that looks very much like an MD5 hash signature. Okay, so that's them logging in again. Not really doing that much there. And we're going to get there eventually. Okay, so here we go. This one looks very strange. This one looks exactly like an MD5 hash signature. So let's actually see if we can get an MD5 hash cracker. Okay, so we'll just go for that one. Just stick in our MD5 here, and let's try and crack that one. There we go. Okay, that's the hash signature for tortoise. Quite strange there. So it looks like it's a strange message that's been passed. Okay, so what we'll do now is that we'll actually have a look on the actual host. So we have the host, and the host is in our cloud. Just let me shut down here. Okay, so the exact machine that we've been analyzing, we can actually have a look at the directory structure, and we should be able to cross-correlate exactly what the user is doing here with what appears in the host. Okay, so we'll just have a quick look to see if we can see any of these files that have been created. Okay, so you should find that the machines are in here. So we'll just pick off a Windows machine. Unfortunately, they're all on. So just let me try this one. This one's fine. Okay, so as much as possible, you need to cross-correlate what you actually see in your network trace with what appears on the hosts. And we just, oops, someone's on that one. Let's try this one. Okay, so we'll get logged into this one. Okay, so here we are. Right, so the inetpub folder is the one that has the main web server and FTP server for this Windows machine. So here is the root folder of the FTP server. Okay, so we can find that out by going to our IIS control panel. Okay, so it's in here. You'll see your FTP server, and then also for web. Okay, so it's in here that we actually set up the home folder, and then the writes that someone can have into that folder. Okay, so that's running, and hopefully I haven't just, yeah, that's fine. Okay, so let's open that again. Okay, so if you follow the trace, you actually see that the user has actually created a folder there, and again, if you follow the trace, they've actually created 2 documents. So if we have a look at manual.txt, that's what's inside it. This is a standard sign of an RTF file. So if we rename manual.rtf to manual.rtf, you actually find that's a rich text format document. And there's another document in there. Okay, unfortunately we don't have the Word installed in that one. But let's just have a little look, see if there's anything we can spot. Ah, that looks a bit strange. So we actually have a hash code, some sort of code. We could very quickly check to see. So that might be a hash signature, or it might be a secret message. Okay, so you might want to try that with hex patterning just to see if it converts, and it doesn't. So perhaps it's an MD5 or a SHA signature that you can actually try it and see if there's any message hidden in them. Okay, so let's go back to our trace, and then the next thing after the FTP traffic, we actually found that there is an awful lot of Telnet activity. So let's have a look at Telnet. Okay, so here is some of the connections. So let's have a look at this one. So this one has a Synac. We'll have a look, we'll follow the stream and then see what the user did. Okay, so you've seen that they managed to get administrator and password, and the password from the Hydra crack. They've then tried Telnet and they've managed to get in because it's the same password in there. So now they're going into the documents. The documents folder, documents and settings. Okay, so they're now into here, and then they've gone into administrator and had a little look around. Okay, so this should be the same as what we have here. And then they've went into the testing 123 folder. Let's see that it's there. So this is what they did. And there's a file called list there. And they've actually did that. And that's a listing of that directory. And then they went and telnetted into the 13 computer, which is the one that they're actually connected to. Okay, so from here we can actually start to look at the connections. So let's just look for the SYN flags to get the start of the connection. Let's try this one. so you can see they've gone into the inet pub directory, cd www root dir cd tor dir, and then they've erased all the files in the tor. So if you actually find this, look at this trace, they use FTP to be able to upload these files, and then what they're doing is they're deleting them, and then they're making them hidden. So this here makes the tor folder hidden. So if we look over here at the real machine, and we're looking for inetpub www root. Okay, so let's go back onto our machine. Okay, so it's looks like that folder is gone. But if we do /ah, we can see the hidden folder, and there it is there. Okay, so the user went in there and actually created this folder. We'll see if there's any hidden files in there, and there isn't. Okay, so you can actually trace what's in there and what they managed to delete, and so on. So the next thing we're going to have a look at is the traces for email. Okay, so for email we use TCP port equal to 25, and this is for sending emails. Okay, so we'll just pick off one such as this one here, and we should be able to follow the stream and watch which email was actually sent. Okay, so this is what it looks like. LO is a standard command that we use when we contact SMTP. This is who the mail is from. This is who gets the receipt. Then data. Then you type in the data, followed by a carriage return line feed dot carriage return line feed. So there we go. There's the message. Okay, so I think you might find if you do a Caesar code analysis of that, that looks very much like the, or that could be the, and you probably find there's a little Caesar code in there for you to crack. And then at the end there's the dot, and then it gets sent. Okay, so we can look at the email messages, and then we look at pop 110 to look at the messages that have been read. Okay, so we'll just pick off one, and we'll try this one here. And this is the reader, this is the person reading. There is nothing in that one, but this is the reading of the emails now. So the next thing that we'll do is we'll have a look at how we can search using a regular expression. So it's 10. Right, so let's do some matching against strings. So a common method that we use is to use regular expressions to be able to match. So what we'll do is we'll match this one. This is a very simple one. It's really any characters, multiple characters of these characters, upper and lowercase z, 0 to 9, a dot, and so on, and then an at, and then at least one character after it. That's going to identify our email address. Okay, so we'll feed that in, and then we just apply, and hopefully that should show us all the IP addresses, all the email addresses that we have in here. Okay, so that's the way that we can search using regular expressions. We can also search for certain contents. So there is a magic file number that we have that allows you to be able to search to identify a file. So in this case we'll load up a PDF file, and there we go. So we always see the %PDF at the start of a PDF document. Okay, so this is known as the magic number for it. So we can do that with our Wireshark trace. So let's do HTTP contains. Okay, so it doesn't necessarily need to match the whole thing. And then %PDF. So let's see if we have a PDF document in there, and we don't. Let's see if we have a GIF file. So GIF 89A. Hopefully we'll be able to find a GIF file in there. There we go. Okay, so we've got a whole lot of GIF files in there. Okay, so then we'll just follow that stream, and we'll actually have a look to see what the GIF file is. Okay, so this is the GIF file here that it's actually loading. Looks a very complicated one, but you see that there's the GIF 89A for the file. Okay, that's a very small graphic there. There's another one. Okay, so GIF 89A identifies that. We can also search for a non-printing type character. So let's say we search for a hex pattern. So 89/50 hex /4E hex /47 is actually a PNG. Okay, so lots of PNGs in there. That is there. Let's pick off one here. So there we go. It's getting a. Just try and find their PNG. Okay, it's PHP server, and we can search for our file, and then hopefully with inside the trace we should be able to pick off our PNG file from in there to search for. Here we go. So that's getting the follow us on.png from this ant farm site. Okay, so the content type is image.png. There's the standard sign. So the dot is a non-printing character, which was actually the 89 hex. Okay, so we can do the same for a zip file if we want to. So JPEG, let's have a look at JPEG. See if we can find out what the magic number is of a JPEG. FFD8. So let's search for FFD8 and see if we can find. Oops. Okay, so it's non-printing, so we'll have to do it like that. D8. Okay, so we've got lots of JPEGs there. We can have a look to see what they are. There we go. So if we just search down, hopefully we'll see a JPEG appearing in there. Okay, it's not there. Just keep going down, and then we should be able to see JPEG. Not there, not there. That's our CSS file. That's a JavaScript file. So these are all the files that are downloaded from our web page. There's another JavaScript file, and there's another one, and then there should be another JavaScript one there, and so on. So if you search through this, then hopefully you'll find the JPEG, and there it is there. Okay, so there's a small ant factory as a JPEG. Okay, the FF is here, the code that we went for. GIF is another thing, that there's a header that we get in a JPEG file called the GIF header, and we can see that from there. Okay, so that shows that in terms of finding a Flash file, Flash is actually identified with FWS, and I don't think there is any Flash content in there. Okay. Okay, so now what we're going to do is we're going to use Snort in the same way that we've used the Wireshark. So this is quite useful to be able to see if our Snort signatures are actually working. We can also use Snort in terms of creating an intrusion detection system, or to be able to analyze our traces. Okay, so what we do is we create a rules file. So the first thing we're looking for is our FTP bad login. And so we're looking for the 530. So let's, to save time, let's just pull this up. And what we want is that rule there. Copy that one. Okay. Okay, so that's going to detect the content of 530 incorrect user login or so coming from port 21 to say that they can't actually log in. So let's see how many bad logins there has been. So we want to get -C, the rules file, then we want -L, so make sure you create your log. We'll create a new log folder. That's where our logs are going to go into. So Snort -C, the rules file, L is the log file, and then our trace is here. Okay, so -R gives you the trace. Oops. Okay, so we need to enable stream 5. Okay, so we'll just grab that from here. Okay, so this is a little bit at the start of the file that we need to add to Snort. Okay, so let's do it again. There we go. Wasn't that quick? Okay, so we can check to see how many alerts were actually caused. 41 alerts. So there were 41 logins there. So let's look into the log2 folder. And we must have used log. Oh, we did. So what I'll do is I'll just erase erase the log folder so that we can start from scratch again. Okay, so that's there. Okay, so there is our alert.ids, and there's all the bad logins. Okay, so we can see there that obviously that's working for that. That gives us the number of bad logins is the number of alerts that we have here. So the number of successful logins, if we remember, I think was 230. 230 is a good login. That's for our bad login. So let's actually go for 230. And let's have a quick look to see what the 230 said. Two thirty. And it's uppercase user, so we're fine there. Okay, so let's try that one. So this will tell us the number of times the user has successfully logged in. This time there are 11 alerts. Okay, so we've got 11 of these. We can count them. 11 there. That's fine. So in terms of GIF, we can pull off GIF. So again, let's actually have a look at the PDF. And this is our GIF one. This time there are 239 alerts. If you want, we can go in and have a look at the alert file. It just keeps building up. Okay, so there's the detail. There's all the image details in our log. That is a trace that we can open up, and we can see all the details that are contained within inside there. And then within inside our alert.ids at the bottom, we should be able to see all the GIF files that were found. Okay, there. Okay, so go ahead and then do the rest. Okay, so there's a range of other things that you can actually do. You can download the traces from this site here. Okay, so download some of the Hydra traces from here, and then we'll just extract that. I'm just going to extract that to the Snort bin folder just to save time. And for that we've isolated these traces. So this is a standard Hydra trace, so you can analyze it. There we go. Okay, there's Synac, Ac, and so on. So you see continually trying lots of different usernames and passwords. And then, so go ahead and just do the same sort of scanning as you did before, but you should be able to detect the threats. So we've also set up a page here that will actually run the rule that you've got So if we're looking for email with GIF and with certain rules, you can actually generate the log file. Okay, but it's best what to do is to do it manually through the Snort command line.